So here we're looking at second derivatives. Okay, and these notes are worth taking for yourself, okay? So second derivatives. So far we had the first derivative of the function, and we call the first derivative dy dx. Okay? Now we're going to find the second derivative, and the notation for the second derivative we call d2y dx2, okay, or d squared y dx squared. Okay, so d squared y dx squared. And the derivative, the second derivative, so what does the second derivative do? Second derivative is simply the derivative of the first derivative. So basically, what you're doing here is you're going to differentiate twice. Differentiate twice. Okay? So your second derivative is just the derivative of the first derivative. The first derivative, dy dx. The second derivative, d2y dx squared. And the second derivative is just the derivative of the first derivative. Okay? So the important thing is, if you can find the first derivative, you will be able to find the second derivative. Okay? Because one is the next after the other. Okay? So you find your answer, and then you find the second derivative of it. Okay? So I'm going to do a few examples here once you have these taken down. Okay? So take down your notes. So if we want to find, so we have a function y equals 4x squared plus 5x minus 7, and we want to find d2y dx2. Okay, so the first thing we have to do here is we have to differentiate. So step 1, dy dx is equal to, so we're going to differentiate, so multiply by the power, 2 times 4x, reduce the power by 1 again, 2 minus 1, 5x to the power of 1 becomes 1 times 5x to the power of 1 take 1, 7x to the power of 0, because x to the power of 0 is 1, gives me 1 times 7x to the power of 0 minus 1. So the derivative will be equal to 8x to the power of 1 plus 5x to the power of 0 minus 0. Okay, so just be careful here, the power was 0. So our answer is 8x plus 5. And that's our first derivative. So step 2, now differentiate the answer for dy dx. Okay, so we have 8x plus 5. So the second derivative, d2y dx2, is equal to, put in our power again, x to the power of 0. So 1 times 8x, power of 1 take 1, plus 0 times 5x to the power of 0 minus 1, which leaves me with 8x to the power of 0 plus 0, which is just simply 8. So you're differentiating a second time, if you like. Okay? So you're differentiating and differentiating again. So that's your first example. Give you a minute to take that one down. Okay. Example 2. Y equals 7x cubed plus 4x squared. Okay. So again, step 1, we're going to do dy dx is equal to, multiply by the power is 3 times 7x, reduce the power by 1 becomes 2, thus multiply by the power is 2 times 4x, reduce the power by 1, 2 take 1 is 1, which gives you 21x squared plus 8x to the power of 1, which is 21x squared plus 8x. Because again, x to the power of 1 is just x. Okay? And after a while, you see you're getting quicker at these things. And now step 2, d2y dx2 is equal to, multiply by the power is 2, 21x, to the power of 2 take 1 is 1, plus, that's the power of 1, so 1 times 8x, power of 1 take 1 is 0, which is equal to 42x, power of 1, plus 8x is the power of 0, which is 42x plus 8. So you have your derivative, your first derivative, and this here is your second derivative, which is the first derivative and the derivative of the answer. Okay? And finally, supposing you have f of x equal to 2x squared minus 6x, and you want to find f dash of x and f double dash of x, which is your second derivative. Okay, so for our first derivative, multiply by the power. Now in this case, f dash of x is equal to 2 times 2x, reduce the power by 1, 2 take 1 is 1, minus 1 times 6x, 1 take 1 is 0, which gives you 4x to the power of 1, minus 6x to the power of 0, which is 4x minus 6. And your second derivative then, f double dash of x is equal to, that's 4x to the power of 1, so 1 times 4x to the power of 0, minus 0 times 6 x, it doesn't make a difference, to the power of 0 minus 1, which gives us 4x to the power of 0, which is x to the power of 0 is 1, so the answer is 4. And that explains our second derivative.